Hi, pre-calcers. This is just a video going over for those of you who maybe missed our Zoom class or who are just hoping to go over the lesson from 12.2 one more time because it's a little trickier and abstract. So, kind of the goal of this lesson is to understand results like this. So, if you haven't done this already, maybe pause the video and just kind of test for yourself and verify that these different pairs of values are all equal to each other. So, I'm not saying in this case the sine of 60 is equal to some other value down here. It's just specifically each pair here should be equal to each other. And that seems kind of weird at first, right? Because if you look clearly, the angles are not equal to each other. So how could the sines or the cosines or the tangents of these angles somehow be the same? And you can test this out on a calculator, and they all check out. So how does this work? What's going on here? So I think the tricky part to these kind of little facts is that the way we learn about the sine, the cosine, and the tangent initially is usually in the context of right triangles. Um, so to really understand what's going on here, we have to get out of right triangles and really put the sine, the cosine, and the tangent in their proper context. One other hint to this is some of these angles are really large, right? We have 240 degrees, 300 degrees. Those are not angles that are going to be inside of a triangle in the first place. So how could we even think about that? If the sine of 240 degrees is supposed to be opposite over hypotenuse, how can we can't make a right triangle that has that opposite and hypotenuse with a 240-degree angle in it. That's impossible. So what even is going on? So before we talk about how these can be equal, we just want to make sure we have one definition clear before we start. And so that definition is this: angles in standard position. So really to really understand where the sine, the cosine, and the tangent come from, we have to get outside of right triangles and just into the coordinate plane and on the unit circle. So just a reminder, the unit circle is a circle with a radius 1 centered at the origin. So these would be unit circles right here. So angles that we're going to look at are no longer going to be just inside of right triangles. We're going to talk about standard position angles. So standard position angles are angles that are always measured against the positive side of the x-axis. So these would be in both of these diagrams here, looking at the positive x-axis here, you'll notice both of these angles are being measured against the right side of the x-axis, the positive, where the positive numbers would be, right? So a positive angle then would be, you could think of as a hand on a clock rotating counterclockwise. So a positive angle will be a counterclockwise rotation from the positive side of the x-axis, and then a negative angle is going to be just a clockwise rotation. But again, the starting point being the positive side of the x-axis. So we're going to be building off of this definition, and now we can start to think about angles that are larger than 180, right? So 180-degree angle is just going to be more than half of a rotation around the circle. Well, that's no problem. We can go that far. Angles like 240 and 300 degrees now are no problem. You're just going, over halfway, somewhere between halfway and a full rotation. We can even go beyond that. We could go 400 degrees. That would just be a full rotation plus a few more, right? So you can keep going around that circle as far as you want, any degree amount, and it makes sense, right? The context it makes sense in this case. We're not limited to just triangles now. Same idea with negative angles, right? What even would be a negative 30-degree angle if we're thinking about a right triangle? If I were to ask you to draw a right triangle and put a negative angle there, I'm guessing nobody would know what to do, right? That it doesn't really make sense. But in this context, it makes perfect sense, right? It's just a 30-degree angle that's going the opposite way. You can go negative 300 degrees, again, over half a rotation in the clockwise direction. You could go negative 400. Oh, that's over a full rotation in the clockwise direction. So angles like these make sense if we're basing it off of these or this definition of an angle. And that's where we're going to be going for in 12.2. Okay, so then we have to understand the sine and the cosine and the tangent differently than we did before. So to understand this, we're going to be thinking again on the unit circle. And what it turns out is if you have an angle in standard position and draw a radius on the unit circle at that angle with that standard position angle, then the point where that radius hits the unit circle is going to have an x and a y coordinate, and we just define the cosine is the x coordinate of that point, and the sine is just the